All right, so more work with the trig functions today. This time we're going to go through and talk about the fundamental identities so that we can discuss more than just the sine and the cosine. And then we're going to talk about the properties of even and odd with respect to the trig functions. So let's get ourselves started. So the first thing that we want to do is just determine or define what are the 6 trigonometric functions. So we already know sine and cosine, and you should already know tangent as well. So we're going to start by putting them into the right qualifiers here. So a reciprocal identity and then quotient identities. Well, if you remember from before, tangent of theta is equal to the sine of theta divided by the cosine of theta. That's called our quotient identity because it's literally taking one trig function and dividing it by the other. So tangent's the first one of the ones that we need to know, and that one is something that you should know from geometry already, so it really is nothing new. However, the other 3 that we're going to learn are completely different from ones that we've done. So our first one is called cosecant of theta, and the only thing that the cosecant is it's the reciprocal of the sine function. So whatever the sine function is, you take the reciprocal, and that'll be the cosecant. That's why it's under the reciprocal identities. And then we have secant of theta. Secant theta is equal to 1 divided by the cosine of theta. Then we have cotangent theta. And cotangent theta is 1 divided by the tangent of theta. So there are 3 reciprocal identities which actually go through and define cosecant, secant, and cotangent. We already have defined sine and cosine in the past. We've also defined tangent in the past as the quotient of sine and cosine. We have one more quotient identity, and that's actually cotangent. So since cotangent is nothing more than the reciprocal of tangent, well, then we'll take the reciprocal of the quotient, which means I can also get it a different way by taking the cosine of theta and dividing by the sine of theta. So these things are 2 identities or 2 groups of identities that we need to have committed to our memory. It's something that you're going to be using over and over again. Another identity that we've already talked about is the Pythagorean identity. We know that is sine squared theta plus cosine squared. Try that again. Sine squared theta plus cosine squared theta is equal to 1. So we can go through and come up with alternative forms to this. The first one that we can do is, all right, so I have my sine squared theta plus cosine squared theta equals 1. And if I decide to divide every single thing by sine squared theta, and again, all we're doing is just coming up with alternate forms. Well, sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta, well, we already know from our previous identities, cosine divided by sine is cotangent, so this would be cotangent squared theta. And from our identities on the previous slide, 1 divided by sine squared is going to be cosecant squared theta. So that's another way at which to write a Pythagorean identity. It's an alternative form. I'm going to grab a different color here and we'll do another form. In this case, instead of dividing both sides by sine squared theta, we're going to go through and divide both sides by cosine squared theta. So divide each of those. And again, this is going to be useful for when we start trying to determine whether or not an expression or an equation is an identity. And again, remember that an identity just means that it is always true, no matter what value. So in other words, when I'm talking about this Pythagorean identity, no matter what value I put in for theta, whether it be in degrees, whether it be in radians, no matter what I put in there, it's going to equal 1. And that's the same thing with down here. No matter what these values are for theta, these things are always going to be true. All right, so sine squared theta divided by cosine squared theta, that's tangent squared theta. Cosine divided by cosine, well, that's going to be 1 divided by cosine squared theta, that's going to be secant squared theta. All right, so these are 2 alternative forms for the Pythagorean theorem, all we did is just reestablish it as a different form, because when we go through and try to establish identities later, we may end up with something that looks like this, and it'll be easier than trying to start out with this kind of an equation or identity. So there are three forms of the Pythagorean identity. All right, next, let's talk about even, odd, or neither. So we'll talk about cosine first. Remember that a function is either even if I substitute negative x in and I get the exact same thing as what f of x would be. And then it's considered odd if I substitute a negative x into the function and I get the opposite of the original function. So let's talk about cosine. So if I take cosine, in this case I'm going to take negative t. So if I look at this on a unit circle, and I'm looking at cosine, and this is the angle that I would have gone, but instead I decided to go this way. Well, remember that cosine is the x value that comes out here. So then I'm going to look through, and when I draw this down, this x distance is exactly the same no matter whether I take positive t or negative t. So cosine of negative t is equal to the cosine of t, which therefore makes this even. If I go through now, I'll use a different color. If I go through now and look at sine, and I take the sine of negative t, all right, so remember sine is the y component, so then that means up here that would be y. This would actually be a negative y value, because remember, each coordinate, right, when we look at the coordinates, x, y, x is the cosine, y is the sine. So if I'm at t, then my value is just y. If I'm at negative t, then my value is at negative y, which means we have the opposite. So that means that sine is an odd function. So cosine is even, sine is odd. Now when we go to graph these, it'll be easier to see. When we start taking some actual values, we'll see that that is actually true. So actually, let's go ahead and do one. So let's say that I take the sine of 30 degrees. We know the sine of 30 degrees is 1/2. So if I say, hey, you know what, let's, instead of doing that, let's take the sine of negative 30 degrees. All right, so normally this side over here would be 1/2. If I look at this, this would be negative 1/2. So notice that when I take the sine of negative 30, I'm ending up down here, so that's negative 1/2. And that just follows that if I take the sine of the opposite angle, in other words, I'm rotating down instead of up. If I'm rotating clockwise, it's going to give me a negative from the original. All right, it's going to just give me the opposite. All right, so what about the other functions then? So, whoops, typo, I should say does, D-O-E-S, not DOS. All right, so what does this mean for the other trigonometric functions? So let's think about this, right? If I'm starting now, I'm going to look at tangent of negative t. All right, so remember tangent is just the opposite divided by the adjacent. So in this case, it would be a positive value if I was at positive t. But down here, it's the, again, opposite, which is negative, divided by the x value, which is its adjacent. So then here, this is, again, negative y. Here, this is a positive y. So if I put in tangent of a negative t, opposite divided by the adjacent, and the adjacent is x, I'm going to end up with a negative value. So this will be negative tangent t. Okay. Now let's think about, let's go with cosecant. So cosecant negative t. Well, the nice thing is, remember the cosecant is nothing more than the reciprocal of the sine. So then if I just flip it, that means the sines, S-I-G-N's, are all going to remain the same. So if sine, S-I-N-E, I know, if sine was an odd function, then its reciprocal function will also be an odd function. Whoops, I don't want to say that. Negative cosecant t. All right, so these two are odd. Well, that also then means if tangent is an odd function, then so is its reciprocal function. So cotangent of negative t is also going to be an odd function. All right, so, oh, man, it's early in the morning. All right, so these are all odd. Now, if I look at the reciprocal function of cosine, and cosine was even, so the reciprocal function of cosine is secant. So secant was the reciprocal of cosine. So then that means that we are going to, man, my pen is not working the way that it's supposed to. There we go. Is also going to be even. Okay. All right. So now we know of all the ones that are odd, all the ones that are even. I'll add in the other functions here, so we know that cosine is even. And that's why I've got them color coded. I'll add in sine at the top just so that we know these are all 6 trig functions, and we know which ones are even and which ones are odd. So there's only 2 that are even, and that's cosine and its reciprocal. All the other ones are going to be odd in their basic form. Okay? All right. Well, aside from the little typos and slight pen malfunctions, hopefully this was helpful for you. As we move forward through our trig unit, we're going to be using these properties often, but I just wanted to make sure that we had it all down in one location that you could easily come back to. So thank you very much, and have yourself a great rest of your day.